आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
In this question, we need to evaluate limit x tending to infinity integration 0 to x e to the power x square dx whole square divided by integration from 0 to x e to the power 2x square dx. Now note one thing, that this limit is in the form of infinity by infinity, since the value of this integral as well as this integral will come in the form of e to the power x of something, and since x tends to infinity, the value of these two integral will be equal to e to the power infinity, and since e to the power infinity is infinity, so we can say that this limit is in the form of infinity by infinity. Now we know one thing, that for limit x tending to infinity fx by gx, which is in the form of infinity by infinity, we can apply L'Hospital rule here, and we can say that it will be equals to limit x tending to infinity f dash x divided by g dash x. So similarly, we will apply L'Hospital rule here, but to differentiate both this integral, we will have to use the Leibniz integral rule, which says that integration from ax to bx ft dt is equals to f of the upper limit of the integral f of bx into differentiation of the upper limit of the integral, that is b dash x, minus f of the lower limit of the integral, that is f of ax, into differentiation of the lower limit of the integral, that is a dash x. So using this Leibniz integral rule, we will differentiate these two. So let us denote it as some I. So I can be written as limit. Firstly, I will write the value of I. I is limit x tending to infinity integration from 0 to x e to the power x square dx whole square divided by integration from 0 to x e to the power 2x square dx. Now we will write I as differentiation of this one and differentiation of this one. Now consider it as x square. So differentiation of x square will be equals to 2 times of x, that is 2 times of integration from 0 to x e to the power x square dx. Now by chain rule, we will differentiate this function. Now this will be equals to e to the power x square into differentiation of x, that is 1, minus e to the power, in place of x now we'll put 0, so e to the power 0 square, that is 0, into differentiation of 0 will be equals to 0, divided by, now we'll differentiate this integral, this will be equals to e to the power 2x square into differentiation of x, that is 1, minus again e to the power 2 into 0 square, that is 0, into differentiation of 0 will be equals to 0. Now we'll simplify it further, so this will be equals to 2 times of e to the power x square integration 0 to x e to the power x square dx divided by e to the power x square whole square. Now e to the power 2x square can be written as e to the power x square whole square, since it will be equals to e to the power 2x square, and here limit is limit x tends to infinity, and here also limit x tends to infinity. Now we'll simplify it further. We will cancel out 1 e to the power x square, and again this is in the form of infinity by infinity, since the value of this integral will come in the form of e to the power x of something, and since x tends to infinity, the value of this integral e to the power infinity into something, that is infinity, and at x equals to infinity, this will obviously be infinity. So this is again in the form of infinity by infinity. We will again apply L'Hospital rule, and we'll differentiate this integral and this function e to the power x square. So this will be equals to limit x tending to infinity, and to differentiate this integral, we will again use Leibniz integral rule. So this will be equals to e to the power x square into differentiation of x, that is 1, minus e to the power 0 into differentiation of 0 will be 0. So divided by differentiation of e to the power x square will be e to the power x square into differentiation of x square, that is 2x. So this will get cancelled out. Also e to the power x square will also get cancelled out. So we got this as limit x tending to infinity 1 by x, and now we can apply the limit. So 1 by infinity will be equals to 0. So we got the value of this limit as equals to 0, and this is our answer.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।